Welcome to the ARC 1 volt DVM Troubleshooting Part 1. We're going to look at the circuit from our 7490 through our op amps. This is basically our DAC circuit, digital analog. This is a working circuit. This one shows the way that the two outputs should look if everything is working perfectly. Here's the output of the waveform for this. Should be our first troubleshooting point, the output of our DAC. And we see here we have a positive going stair step, the red. That is our output that we're looking for. And if it's got 9 steps, it's good. And this would be from the other op amp coming right out of our DAC. This would be after we do the one-to-one inversion with an inverting op amp. Here's the same working circuit, except now we're taking a look at the BCD output of our 7490. BCD is binary coded decimal, and this is a good output of that circuit. Here's the output of our 7490, the BCD. Here's our start of our pattern here, and we're counting 0 through 9 and repeating. So this is the waveform we should be looking for when we're doing our troubleshooting. The oscilloscope may have problems picking up this signal because it's not periodic, and don't worry about that, that's normal. Okay, here's our circuit, and we broke R6 on this side here. So we're going to look at both sides of that circuit, and we're picking it off of our input to the DAC. And we're going to look at the output. Here's our waveform with our cut R6. So R6 is QD, so it's going to be a 1-bit. And if we look here, we have 1, 2, 3, 4, 5, 6, 7, and then open. So we have this broken piece here. So it's not a good stair step, and it's damaged in this way. Here is that BCD QD output with the 2 pulses. That's normal. And anytime that we have a cut component like that, a circuit, that we're going to get the same reading on both sides of that component, showing that it's cut. The cyan waveform here, this is at the virtual ground. This is what you're going to see there. You can see 0 with some noise on it. That is the part of the op amp that is the virtual ground, so you're not going to really get a good measurement there. Here's our circuit again. This way we cut R5, we put R6 back together, and again we're looking at our input to the op amp and the cut circuit. Here's our waveform of the cut of R5, and you notice that the stair step is really messed up. Okay, so it's not close. Anytime that you see a stair step that has any damage to it, that means one of our resistors are cut. Here's our QC output, 2 pulses. That's normal, and again it's cut, so we're going to see the same output on both sides of the component. And again, here's our virtual ground signal. Here we repaired our 2 bottom resistors, and we cut R4, and we'll take a look at that. Here's our cut circuit again, and we have a very messed up output of our stair step. And again, we have our 2 pulses coming off of QB, and that's normal. And here again is our virtual ground. So here we have our damaged stair step, and that's going to point us back to those resistors. Here's the circuit, and we've cut R3, and we're going to go take a look at the output. Since we cut R3, we lost our divide by 2 circuit. So we're a divide by 5 now, and that should be pointing us back to that input. So back, we're only running the divide by 5. This is the good QA signal, and back to our virtual ground. Here we cut our feedback between QA and clock B. And let's take a look at the output. Here we show just a divide by 2. That should be reasonable since we have our divide by 5 cut. Here's a circuit where we've cut our feedback resistor to our first op amp. Let's take a look at the output. Here's our waveform from the cut to feedback resistor, and we notice on the red that we have gone to the rail. So it's since we have no feedback, no negative feedback, we can't control the gain, so it goes to maximum, which is limited by our 12-volt power supply. And the yellow one here is after it goes to the inverting 1-to-1 op amp, it goes positive. So here's our first signal, and here's the output, which we'd be looking at as our test point 1. And we see here at our virtual ground, we're getting a signal from the resistor pack. Here we've cut the feedback resistor for the final op amp. Let's take a look at the output. Okay, here's our cut feedback resistor R9. Here's the output of our the DAC. It's good. All right, the next one is cut, and what happens is since that resistor is cut, we have gone to the maximum here to our rail, and since it's tied to that resistor who's cut, it's also going to the rail. I've offset them a little bit, but they both maximize, go up as far as they can.